to determine if our function is 1 to 1, we apply the horizontal line test, where we take any horizontal line, and if any horizontal line touches the function more than once, then it is not 1 to 1. Okay, so looking at any horizontal line, I'm going to use my ruler tool, create a horizontal line. Now as we move this around, no matter where we put it, this line only touches the curve in one spot. So this passes the horizontal line test. So for part A, f is 1 to 1. Because it passes the horizontal line test. For part B, we want to determine the domain and range. And because there are no arrows at the ends, we're just going to assume that what we see is the entire thing. So for f, our domain is all our possible inputs. So we go to the furthest left point, which is down here, and find where that corresponds to the input. So looks like it's right around there. And we're just going to estimate that. It looks like maybe it's negative 1.1. And then go to our far right point over here and drop that down. It looks like that's maybe just a little bit bigger than the 3, so maybe 3 point, maybe 0.5. That's just an estimate. Okay, and then we do our range. And so we're looking at our possible output values. So we go to our bottom point, come over. Looks like that's going to be at about negative 1.25. And then our highest point, come across. And it looks like that's going to be right around there, maybe 1.7. For part C, for f inverse, we have a wonderful property that is, for inverse functions, our domain and range simply flip. So our domain of f inverse is the range of f. So from negative 1.25 to 1.7. And our range of f inverse is the domain of f. So negative 1.1 to 3.05. Okay, for part D, now we've got to evaluate f inverse of 0.75. So this equals some number, I'll call it x. And for inverse functions, that's the same thing as saying that f of x equals 0.75. So I simply find, here's my graph for f, so I find where's my output, 0.75. And connect that over to our curve, and then connect that down. And that connects down right there at 2. And so this happens for x equals 2. Okay, meaning, of course, that f inverse of 0.75 is equal to 2. And finally, for part E, estimate the value of f inverse of 1. So again, we go to where our output was 1 and connect that over to our curve and connect that down. And then we just want to estimate that point right there. And so it looks like that's at about 2.4. So we'll estimate that f inverse of 1 is approximately 2.4.